Okay guys, so welcome to the Naresh technology, and today we are discussing one of the problem statement, which is the power of a number. First we'll discuss about the normal recursive approach, and then we'll try to optimize that problem by applying the divide and conquer strategy, right? So let me introduce first about the problem statement. So suppose you have to find out the power of a number. Suppose I have a number a and the power is given n, right? So you have to find out the a power n. Okay, so the normal recursive approach, first of all we'll see. I hope that everyone know what is recursion. So recursion means we are calling the function again and again until some condition will get satisfied. That's why we call it as recursion. And to write down the recursive solution, we have to find out two steps. First one is anchor step, another one is recursive step, right? These two steps we need to find out. One is anchor step, another one is recursive step. Now in case of a power of a number, suppose my a value is 2 and n value is suppose 4, right? Means I need to find out the value which is a 2 power 4, correct? So 2 power 4, right? So first of all we'll see the brute force recursive approach, and then we'll move towards the divide and conquer strategy, right? So what I will do, we know that suppose I am writing 2 power 4. 2 power 4 means you are multiplying 2 4 times, correct? So we got to know this is our repetitive step, that we have to multiply repeatedly. This is our recursive step. So we got to know that this is our recursive step, right? Now what will be the anchor step, right? Now what will be the anchor step? For example, let's consider the same example, which is a 2 power 4. If I multiply 2 one time, then how many times 2 is remaining to get multiplied? I can say that 2 is getting remaining 3 times, right? Again, if I am writing like this, 2 into 2, if I multiply 2 again, how many times 2 is remaining to get multiplied? Again 2 times, right? Similarly, I will continue this, right? 2 into 2 into 2 into 2 comma 1. Can I write like this? Right. Now equals to 2 into 2 into 2 into 2 into 2 comma 0, right? Means now you don't need to add the 2 here for the multiplication. When this n value will become 0, you have to return 1. That's why we know that a power 0 is a 1, correct? So here what will be the anchor step here? 2 power 0 will be the anchor step, where exactly I need to stop multiplying the things, right? So this is my above one is my recursive step, and this is my anchor step, correct? So with the help of these two steps, we can code this problem statement, right? Now I will write this in a generalized way, that how exactly we are writing a function. So I'm writing here recursive power, or let me write down like this, power of 2 comma 4, or suppose 3 comma 4. Okay, let it be 2 comma 4. So I can write like this, 2 into power of 2 comma 4 minus 1, correct? Like this. Similarly, again there will be the function call. I can write here 2 into 2 into power of 2 comma, now this time 3 minus 1, correct? Now again I will multiply, so 2 into 2 into 2 into power, I can write here 2 comma 2 minus 1, right? Means one time. Again I will write here 2 into 2 into 2 into 2 into power of, can I write like this directly, 2 comma 0, and whenever it will become a 0, I can directly return the 1. That will, because that will be my anchor step. So 2 into 2 into 2 into 2 into 1. This will give me the 16 answer, right? So if I'm writing this function in a generalized way, so I can write like this, right? I can write like this, power a comma n equals to, I can write here a into, correct? I can write a into power of a comma n minus 1, correct? When the n value is greater than 0. But when the n value will become 0, you have to return 1. This is your anchor step when your n value equals to 0, correct? Now let me code this thing, that will be the better. So I am writing the function here, see. So def of recursive power, I am passing the argument a comma n, right? Now next, what will be my anchor step? If n equals to 0, then I have to return 1, correct? Else, if this is not the case, then my recursive step will be there, return. I can write here a into recursive, I can write the same thing here, recursive power, I can write a into recursive power of a comma n minus 1, correct? This is the way. Now I have to take the input a equals to, I am telling int input enter any number, correct? Now user will give me any number. I will type here n equals to int input enter the positive power, because we are not still handling this boundary cases, what will if the negative number power will come, right? So enter the positive number power, correct? Now same thing I am passing here in the function print. I am writing here, this is the code, I am passing here a comma n. Let me run this code. Suppose I am writing 2 power 5, I am getting the answer as 32. Now this code is working fine, right? So suppose I am trying to find out the time complexity for this one. Now my n is 5. So how many number of functions call will be there? Maximum 5 functions call will be there. So if I try to calculate the time complexity for this recursive code, so generally whenever we are calculating the time complexity for the recursive code, it will be the number of functions called. So how many times the function call is going? Maximum 5 number of times. So in this case, the time complexity will be order of n, right? But I have to solve this question in log n time, which is the half of the n, right? Now how to solve? For that I will use this strategy called divide and conquer. What divide and conquer strategy will tell us that you consider, suppose you have a problem P, right? And you are assuming that that problem is a large problem, then we are trying to divide that problem into the sub problem. You will continue this process until that problem will become a small problem. When the problem will become small, when the problem is solved in 1 or 2 iteration, right? So I'm using the same strategy. Instead of calling this n number of function call, I'm trying to reduce this number of function call. If I somehow able to reduce this number of function call, automatically my time complexity will get reduced, right? So I'll write here def divide and conquer power, correct? I will write here divide and conquer power. I'm passing same thing a comma n, right? But what's the logic here? What's the logic here? What I'm trying to say? Whenever suppose you have a scenario like this, right? Whenever I am telling that whenever n value is even, correct? Suppose I am writing 2 power 4, 2 power 4. So I can write like this by using law of indices, 2 power 2 into 2 power 2, correct? So it will give me 2 power 4. So if I pass the function for 2 power 2 and only, I don't need to pass this remaining 2 power 2, because I will directly get the value of 2 power 2 here only, right? Through the function call. So here I am not passing here I am not calling the function n number of times. Here I am calling the function approximately equals to n by 2 number of times, right? So ultimately our goal is to reduce the number of function call, and which is possible with the help of this strategy, right? And what if the n is odd? If the n is odd, what we will try to do? I can directly say that you do the n by 2 multiplied by n by 2, right? This number of time you have to call, correct? And then finally, can I write like this? Suppose I have number, suppose I am writing 2 power 5. So I can directly write like this, 2 power 2 into 2 power 2 into 2. That will give me the answer, right? So if the number is even, it is sorted, right? But if not a even number, if it is odd number, you can do in this way, correct? Fine. Now let me code this. Okay, so same thing, if n equals to 0, it has to return 1. It has to return 1. If this is not a case, I will write elif n mod 2 equals to 0, then what I will do, I will take one function called res, variable called res, and I will pass this, I will call this function divide and conquer power. In this I will pass a comma n floor division 2, right? Every time I'm passing, because it will give me the value of n by 2 function calls, right? Then what I will do, I will return result res into res, correct? Now what if the number is odd? What I will do, if the number is odd, I will pass again res equals to divide and conquer power, and I am passing here a comma n floor division 2, correct? And this time I am returning return res into res into a, correct? Now let me check here, I will take the same input, for example, so let me paste it here. Now I will call this function, I am giving here 2, I am giving here 5, so you are getting a 32, right? Means it's working fine. So let me run it for other kind of input, 2, 8, it is giving 256, means your code is working fine. Now if you check here, in this case also I am calling n by 2 function call, here also I am calling n by 2 function call. If you try to analyze the time complexity for this one, let me show you. See, here it will take 1 unit of time, which is order of 1, correct? From these two things, either this will execute or this will execute, right? So if you calculate the time, if I am considering this is the total time is t of n, this will take order of 1 time, and this, because any of this two things will be executed, right? So this will take t of n by 2 time, or this will take t of n by 2 time, but any of this is executing, right? So what I will do, I will form a recurrence relation here, right? So you are getting here t of n, I can write like this, t of n equals to t of n by 2 plus 1. If you observe that this recurrence relation is same as the binary search, this is the same recurrence relation for binary search. If you solve this by using back substitution, you will get the time complexity as order of log n. If you don't want it to solve a recurrence relation by seeing the code also, you can directly say that here there are a total number of function call will be half, that's why it is half than the n value, so that's why it will be considered as the log n. So these are the two different approaches to solve this question, but still we have not handled any boundary case. What if the power is negative, right? That we will see in the next class. Okay, fine, thank you.